Hi everyone. In this video, I explain what references are. I also talk about the null keyword and demonstrate how to compare references. I have a class here named car. The car has a set of member variables. It has a member variable isLightsOn of type Boolean, and it has a member variable named speed of type integer. It also defines a set of methods. It defines the methods turn lights on, turn lights off, speed up, and break. And finally, it has the toString method that returns a string representation of this class. This simply concatenates a string with the values of the two member variables. Now, if you still have questions on this class or if anything is confusing to you, please check out my other video on an introduction to object-oriented programming, where I cover this class in detail. I put a link in the description below. Now let's dive into references. Let's say I have a variable named car1 of type car. This variable essentially holds a reference. And at this point, this doesn't reference anything. I have not yet initialized this reference. And I also have not yet created an object. For example, if I would try to call a method on it, let's say I try to call speed up, I will get a compile error that this complains that my variable car1 has not yet been initialized. So let's initialize this to a new object. Let's say new car. New allocates new memory for a new object. So whenever we use the new keyword, we create a new object. And this operator returns a reference to the object. So car1 stores a reference. Now let's look closer what this looks like in memory. So in memory, we have an object of type car, and this object has member variables. It has speed and isLightsOn. Speed is initially 0 and isLightsOn initially false. These two values come from my declaration of the two member variables. So isLightsOn here, I had false, speed I had 0. If I were, for example, to initialize this to true, initially when I create a new class, this would always be true initially, and then I could obviously change it later. Now the identifier here is my variable car1. So I have car1 that references this object. So if you're familiar with C++, a reference essentially is a pointer, but we cannot manipulate the address of this pointer. So it's really a pure reference. Now what happens if we call a method on this object? Let's say we call speed up to 30. This will change the variable here to 30. And let's say we create another object. If we create another object, essentially we have now two objects in memory. Second one is still 0. So let's type this in here. Create car2 equals new car. So when you have two variables, car1 and car2, car1 stores the reference to the first object, car2 stores the reference to the second object. Car1 is already driving at 30, car2 is still parked because we have not sped up car2 yet. Now let's output these two objects. So I have car1 to car1, and then I also output car2. Now concatenating an object to a string will by default automatically invoke the toString method and then return the string representation. So when I run this, I get the output for the two objects. So the first one is 30 and true. The car2 is 0 and true. So this is what we expect in memory. We have two different objects. Now, what you have to be aware of is that most of the time you have a variable for each object. But you could also have multiple variables that reference the same object. Let's say, for example, I create a variable car3, so of type car, named car3, and I initialize this to car1. This will create a new reference, car3, but now the assignment copies the reference from car2 and stores the reference in car3. So essentially what is happening, since the reference is the same and the address of the reference is the same, they both reference the same object. Now I did not create a new object. I still have just two car objects because I only called the new operator twice. But I have three variables. And now car3 and car2 reference the same object. For example, if I would now do car3 dot speed up to 100, and let's say I output car2 and car3. So let's move this around here. And I put some dashes before that we can easier see it on the output. So let's run this. And then we see now we have car2 driving at 100 and true, and car3 driving at 100 and it's true. So this one here is 100. This assignment simply stores the reference of car2 and car3. And now calling speed up to 100 manipulates the object. But since both these variables reference the same object, both of them will return 100 and true for these two variables. Now let's talk about the null keyword. So let's say I create a new car named car4. And this, I don't want to create an object yet because I don't know what the object is going to be. So I have the option to initialize it to null. Null essentially means nothing. So when I have my car4 variable and I reference null, null means nothing. So that means it has not yet been initialized to an object. It does not reference an object. Now, why would this be useful? This is very useful if you want to check if a variable references an object or not. For example, we could have a condition. If car4 equals null, then we output a string car4 does not reference any object. Now if I run this, we can see car4 does not reference any object. Now, if I know this, I could, for example, say if it does not reference an object, let's create a new one and then references. So null is always good. If we don't want to initialize something, we want to explicitly set it to null because this way we can compare and check it later. If we don't initialize it here, local variables will not be default to null. So you can see that this comparison fails. So it's always good to initialize to null. Now the last thing I want to cover is comparing references. Let's say I want to compare car1 and car2. So for that, I have car1 and I speed up to 50. I use car2, speed up to 50 as well. And then if I go back to my drawing board here, car1 is now 50 and car2 is also 50. And I want to show this on the output. So I output the two. And let's add a dashed line in between so we can see this. So we can see car1 and car2 driving at 50 both have the lights on. So they're exactly equal in terms of the values. But if I compare this now, so I output car1 equal car2. Instead of putting this in a condition, I write it here and I output the Boolean value that this evaluates to. So car1 equal car2. Let's output this. So this one is false. Now let's do the same with car2 and car3. So we can see here that car1 and car2 have the exact same values, but when I compare them with the equality operator, it returns false. When I return car2 and car3, it returns true. So what I demonstrate here is that the comparison operator compares references on objects, not values, okay? So if you want to compare values, there's an equals method. I covered that in a separate video. But when you use just references, remember you only compare if it's the exact same object. You don't care the values. The values can be different. They can be the same. So I showed here that they are the same. It still returns true. So just be aware of this when you're comparing references. I hope you enjoyed this video. Thank you for watching.